Let's make a list. Possible physics variables that might affect the egg drop for this. Maddox, start me off. What is something that you think might affect whether or not the egg will break, the force on it? Acceleration, I like it. All right, Dayton, give me another one. Velocity, good. All right, nice. Sawyer, give me another one. Gravity, I like it. Okay. Michael, give me another one. Okay. So the third law, so equal and opposite reactions. Okay. Good. Connor, give me another one. Mass, I like it. Okay, good. Dalton? Okay. Any others that you guys can think of that aren't there yet? Yep, Benjamin? Huh? Applied force. Okay, good. Yep, Wesley. Inertia. Good. Yep, good. Isaiah, what you get? Say again? Drag, good. Good. Any others? Okay. Let's go through and let's narrow the list down. Now, if I'm crossing yours out, that's not a bad thing. I'm just narrowing it down to ones that we can test. Because some of these we can't really test, and some of these are actually you're going to see the same thing, or at least affect each other. So, acceleration. So, Maddox, when you're talking about acceleration, are you talking about the acceleration of the egg, or what are you talking about with acceleration? Like, how fast it's speeding up, slowing down? What are you talking about?
Speeding up.
Okay, so like the rate at which it falls. Is that kind of what you're talking about?
Pretty much.
Something like that? So, I'm going to cross that out only because gravity explains that a little bit better. Okay? So, nothing wrong with acceleration, but gravity explains that a little bit better. Velocity. Dayton, what do you mean by velocity? Good, like when it gets to the ground. So, do you want it to go fast or slow when it hits the ground? Slow, okay. And ding, 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 we have a winner. This is our first one we're going to add to our list. And make sure that you have it on your list. Velocity, specifically that you want it to be going slow. Okay? Okay, gravity. So the rate at which it falls. Gravity is definitely going to be a factor. However, I can't change gravity because I don't have permission to take you on a field trip to the moon, unfortunately. Also, gravity is going to cause it to accelerate, giving it a velocity. Velocity is going to be the better way to explain that. So gravity is also a good one. It will definitely have an effect. But velocity is a better way to describe that for our purposes. Okay, Newton's third law. Every action has an equal and opposite reaction. That is definitely going to happen at the ground. But we need a way to measure that. There's not a good way to measure this. This is definitely going to matter, but we need a better way to measure that, which we'll come to a little bit later. Mass, definitely going to be a factor. And that is something that we can change. However, the ways of doing this are kind of contrived. Like, for example, all eggs are pretty much the same size. So, like, I suppose I could give some groups quail eggs and some groups ostrich eggs and some groups, regular chicken eggs. But I think we all know how that would go. The ostrich egg group would be hosed, and the quail egg group would barely even have to break a sweat. They'd just be like, oh, I drop it and it's light as I'll put one sheet of paper under it. It'll be fine. So mass does definitely have an effect. We are not going to test it in this lab just because the results are underwhelming. But mass definitely is a factor. Applied force is similar to this Newton's third law. There's going to be some force at the point of impact, but force is hard to measure. We need to be able to measure something else. Because if you think about it, dropping like an egg on, say, like a pillow or something like that is going to have a smaller force, but we need to ask the question why, which we'll get to in a second. Inertia, like these other ones, is going to depend on the velocity. To an extent, again, inertia has to do with mass more than that, but we're going to get into a concept this chapter called momentum, which is inertia in motion. So this is something we'll come to a little bit later, and drag also goes with velocity. So what we need to do is figure out, how do we measure these two things? So I gave the example of a pillow. What do pillows do? Well, pillows spread out the collision. They make it so that the collision doesn't happen very quickly, that it happens over a longer period of time. So the last thing we're going to measure is going to be time, believe it or not. But it's not fall time, it's collision time. It's not how long it takes to fall, it's how long it takes to stop. And we want this to be long. We want this, that's not how you spell that word. We want it to be long, which sounds weird. Why would you want a long collision? You would think long collisions would be bad. But they're not. You guys are actually very familiar with long collisions. You have one every single day, probably. Can anyone think of a long collision that happens to you every single day? Why am I asking this? You're not good. Oh, what do we got?
Car?
Yes! Look at you! I like it. Cars. Every day you use the brakes. You don't have to use the brakes. Did you know this? You don't have to use the brakes to stop. You could run into things. Right? That would also stop you. Okay? It would be effective. If you wanted to stop at an intersection, just run into the light pole. That will stop you. It will make it so that you can't go anymore, but it will stop you. Long collisions make it so that you spread the force out instead of doing the force all at once, and that matters a lot. Just like how fast it's going when it gets to the collision also matters. So, I want you to do the same thing we just did, but now you're going to answer a new question. Number 2. What are some practical ways that you can apply the above principles to your egg? These two principles, slowing the velocity, lengthening the collision time. I want you to come up with at least one example of each on how you could do this. Give me at least one example of each on how you could lower the velocity in a collision, increase the time in the collision. This does not need to be specific for this lab. So don't limit yourself to just using paper and tape yet. Instead, think about, in general, how can you do these things? All right, take a minute to do that part for me. And write them down. Okay, so a couple examples of things you could do. So for adjusting the velocity, you could do things like use a parachute so that it falls slower. Again, you're talking about how fast is it going before it hits the ground, before it stops. And for the time of the collision, you want something that will spread the time out. So that's like some sort of like crumple zone for the time. Think about car crashes.
Okay, I have two ideas right here.
Hold on. So for the velocity, or for the time, so sort of crumple zone, kind of like what you would have in a car wreck. Cars are designed to crumple so that they spread the time out of the collision. A longer collision is going to be better. So then what you need to do is sketch out what you believe a good design would be for your device. Again, 5 sheets of paper, 1 meter of masking tape. It needs to be a drawing, and then you need to explain what the drawing shows regarding these things here. So how does it relate to slowing down the egg when it falls? How can you make the velocity minimized? What does it have to do with lengthening the collision time? You don't necessarily have to do both in your design, but it's a good idea to think about both because that'll make you more likely to be successful.